Okay, sorry for that. So what we're gonna do is we're gonna use p to estimate 1 over e to the power 1 over the square root of e, right? So we're gonna say this is 1 over square root of e. Now here is the thing. So what you might think in such a situation is okay, we use this as our x. Wrong. We don't use that as our x because we have not been taught to say approximate x is equal to this, right? We haven't been taught that this is equal to x. We've been taught to approximate it, right? So mean we're supposed to find our x. And how do we do that? Well, this we know that it's the same as us saying 1 over e to the power 1 over 2, which using some algebraic nonsense there, I can say this is equal to 1, or I can say this is e to the power negative 1 over 2, right? That's good. From this now, it looks like it's starting to look like our function. So what I'm going to do is that I'm then going to equate this. So let me use these guys here. I'm then going to try and equate this to my function, which is e to the power x minus 1 over 2, and then I'm going to solve for x. Now to solve for x here, I'm just going to have negative 1 over 2 is equal to x minus 1 over 2 there. This is just going to be negative 1 is equal to x minus 1, and then from this we can just say x is equal to 0. So the egg we're actually saying in this question, we're actually evaluating where x is equal to 0, not x is equal to 1 over square root of 1 over square root of e. Trust me, if you make that mistake, you'll be giving yourself a lot of work for no marks. So x is equal to 0, right? We're going to solve for this one, and then all we're going to do here is that we're just going to plug it into our function, right? So what we're then going to do here is let me just plug in, let me just copy this. So add to new page. Okay, so what I'm going to do here is I'm going to plug it in there, and then I'm going to say x is equal to 0. So remember x is equal to 0. Then we're going to plug that in. So we're going to say p of 4, then we're going to plug in a 0 there. This is going to be 1 plus, and it's going to be 0 minus 1, right? 0 minus 1 over 2 plus 0 minus 1 squared over 8 plus 0 minus 1 to the power 3 over 48 plus 0 minus 1 to the power 4 over 384, right? Okay, we're going to do that, and then quickly this is just going to be 1 minus 1 over 2 plus 1 over 8 minus 1 over 48 plus 1 over 384. We're gonna plug that in, and if we punch this on our calculator, I already solved this anyway, but just for the sake of clarity, 1 over 2, right, plus 1 over 8 minus 1 over 48 plus 1 over 384. This gives us something like 0.606770831. Yeah, something like that. So this is the result that we get from this, right? So this is the result that we get from this approximation. Okay, very good. Now for the last parts, in fact, for the last parts, I'm going to leave this to you as an exercise. So I want to find the error bound. So what is the error bound for this estimation, and what is the relative error for this estimation? Now for the error bound, so just as a hint, so for the error bound, what we're basically going to be doing is we're going to say we're going to use the error term R4 of x being equal to f the fifth derivative, then this is going to be the epsilon of x, right, then over 5 factorial, then it's going to be x minus 1 over that. So I'm going to find that the error bound, and then remember, when you're doing this, remember our x is evaluated at 2 points, either 0 or 1. So for the error bound, what you're going to do is that you're going to try both of them and see which one gives you the biggest error. Right, you're going to try both of these. You're going to try 0, and then you're going to try 1. See which one gives you the biggest error. And from what I calculated, this should give you something like 1 over 3840. You should get something close to this. So this is something like this should be your answer, right? So something like this should be your answer. Okay, and then for the relative error and absolute error, yeah, we're just going to say, what did you approximate? So this approximation we made, right? So this approximation, so for the absolute error, it's just going to be equal to the actual value itself, e to the power negative 0.5 minus the approximation that we made there, right? The approximation we made in the previous question, then that over the actual value again, and that will give us our relative error for this question. So that's how you're going to approach these, and you can just share your solutions with me to verify. Yeah, bye.